So electronics of WISA Woodsat are based on CubeSat. So it has some similar components. For example, the processor is from the same processor family from STM, the cameras are same and so forth. But of course, because of the requirements coming from the environment of space and security aspects of space missions and so forth, in the end, the electronics are tailor-made for this satellite. So something that would be never needed for CubeSat, for example, is the duplicated radio lines you can see here. So all the components, like you have two of all of the components, so that if one has any problems, the one can take over. For example, here you can see the RS485 transceivers, which you have two pairs of, and also the radio lines here are duplicated. So we have two of the critical components, so that if one fails, you still have one left. This is just to make sure that everything is successful, even if there is, say, radiation problems or so forth. So WISA Woodsat electronic stack consists of 5 different subsystems, which are divided on 4 PCBs. So the bottommost PCB, which you can see here, has the camera subsystem as well as the radio subsystems. And on top of that, we have the onboard computer, which houses the memories and IMUs to support the mission and run basically the spacecraft. On top of that, you have the batteries and the electric power system, which of course takes power from solar panels and converts it to suitable power for rest of the subsystems. And on top of that, we have space for the onboard laboratory coming from European Space Agency, which takes measurements of the wood and on sensors aboard. So here inside you can see the electronic stack we spoke of, and then the whole thing is supported by this main frame and also the wooden panels. And the wooden panels have not only the solar cells but also the atomic oxygen experiment from Estonia. So you have one of these on top of the solar panel and one inside. You see here, and then we measure the difference between those two to get the required parameters. And here in the bottom you have the deployable camera boom, which is designed by Hult and 3D printed by Delva. And here are the antennas. So this other antenna is actually also used as a latch for the camera boom. So it opens from here to here, and then it first acts as a latch, and then it transforms into the second antenna of the satellite.